So let's talk about non-natural boundary cases. So far, we deal with the cases where the subnet mask ends on natural octave boundaries equally 255/8, and this one is /16, and this is /24, right? So it's obvious. It's nicely the subnet mask nicely end on this natural octave boundaries 8, 16, 24. But subnet masks do not have to end on non-natural octave boundaries. So this, let's say this is example, right? You have, this is IP address, oops, and then this is subnet mask. So as you can see, 240, right? It's no longer 255. So you know that the first 2 octet is nicely is all ones, right? It's all ones. And since the third octet is not 255, in such a case, you need to convert this decimal number to binary. Okay, so step number 1, when you have the subnet mask like this, if this number is not 255, step number 1 is to convert this number into a binary form. Okay, and then for this, even for the IP address, you know the first 2 octet, right? You know this obviously from this. You know that first 2 octet is a part of the network address, right? So this one you don't really have to convert it into binary form. But this one, since the 240 is not 255 and this is a third octet, the 16 is better to convert it into the binary form. Okay. So the first 2 octet you don't have to, because it's obvious that this is a part of the network address. The 16 is in the third octet. Just like a subnet mask, it's better for you to convert it into the binary number. So example, so let's take a look at the example. 172.16.0, right? So let's just first take a look at the subnet mask. The subnet mask is what? 255.255.240.0, right? And you know that this first 2 octet is all like 1111 all the way to 1111, right? And then so 172.1, you don't have to convert it into the binary form, but since this is no longer 255, you have to convert it into the binary form. This is step number 1. And then also 16 is on the third octet, so it's better to convert it to binary number. Okay, so anything after this, it's better to convert into. If it's a decimal, you have to convert it into binary form. So the example is, let's say 172.1. Right? And the 16 is, if you convert it to 16 into binary form, it's going to be 0001 0000. That's a 16. And then this is 0, right? So 1, 2, 3, 4, 5, 6, 7, 8. Okay. And then the subnet mask, right? The subnet mask is 255.255. And this is 240, right? So 240, the binary number for 240 is 1111.0000. Oops, yeah, 0000000. So that's a subnet mask. But like the previous example, like in the previous lecture, right? We learned. Let's look at the previous lecture. Okay, so this is example that the previous lecture, you know, the subnet mask ends on the octet boundary. So the left side is the network portions and right side is host portion. And the subnet mask will tell you where you should draw that boundary line, right? Exactly the same idea is going to apply. The same idea is that where the 1 ends, right? So this is where the 1 ends. So this is where the 1 ends, right? So right there you need to draw this boundary line. So you know that this left side is a network portions, and the right side is a host portions. And so let's just draw the IP table, just like previous example. We'll just draw I'm going to draw the IP table. You know, the first address is a network address, right? And then in the first address is obviously your host portion is all 0, right? That's another definition of the network address. So 172.1.0001, right? And then the host portion is going to be all 0. So that's a network address. So 0000.00. Okay, so that's a network address. And the network address is 172.1. So this is what? This is a 16, right? So 16.0. So that's a network address. And then the first usable host IP address is 1 more than this number. So you can make a guess, right? You don't have to really write a binary number, but 172.1.16.1, right? But let's just write it down. 172.1.0001, and then 0.000.0.000.0.001. So that's your first usable host IP address. And the next one, the second usable host IP address is 172.1.0001. Network portion is going to be all same. And then there's a dot here. And then 0.000.0.010, which is 172.1.16.2. Okay. So this is a second usable host address. So I'm going to just keep going, right? And then maybe somewhere, as the lecture slide shows you, somewhere in the middle, right? Just keep, you can just write this IP address, but somewhere in the middle you have this number, right? This number is, for example, so this example is somewhere in the middle you have 172.1.0001, right? Then dot, and then this is 111111, 1 2 3 4 5 6 7 8, right? So this is what? 172.1 dot. So this is still 16. And then this is going to be 255, right? This is 255. The IP address right next to this is 172.1.0001. And then if you just add one more, it's going to be what? 0001 here. And then everything is going to be 0. So this IP address is 172.1 dot. This one, right? This one is a 17. So 17.255. Okay. This is going to be the host IP address, right? And this IP address is going to be somewhere in the middle in the IP table. Okay. So let's see. Then, right. Then I have to So I'm going to ask, hey, what is the broadcast IP address? What is the broadcast IP address? So let's just find the broadcast IP address. The broadcast IP address is it's going to be the last IP address, right? So it's probably somewhere in the middle. I mean, somewhere. Sorry, it's indeed the last. So the broadcast IP address is, you know, that it's the last one. It's 172.1.0001. And then you know that broadcast IP address, the host portion is going to be all ones, right? That's the definition of the broadcast IP address. So the 1111 dot, and then 11111111, right? So that's a broadcast IP address. And so, by the way, for the test and for the quiz, decimal number is what I want. So when I ask you to, okay, what is the broadcast address? You have to always give me the decimal number, right? It's not the binary form. So we know that this is, what? This is a 255. So your IP, and then you have to convert this to a binary number. So I'm going to skip this. So I believe that you guys can do this. So I'm going to take a look at the slide. But this is a number that you have to convert to a decimal number. If you just convert this, then it's going to be this one, right? It's a 31. So assuming that you do the calculation, right? I'm going to skip that part. I believe that now you can convert this to a decimal number. So this is what? This is a 31. That's after you compute. After you convert this binary number to a decimal number, you have 31. I'm going to skip this part, this process. So the number is what? 172.1.31.255. So that's the broadcast address. So this is a broadcast address. And then what about the last usable host IP address? The last usable host IP address is like what? Basically, you can get the last usable host IP address by what? This broadcast address minus 1. Right? If you do that, then you can get the last usable host IP address. So the last usable host IP address is 172.1.0001, right? And then I believe that it's going to be same dot 1111110. It's one less. So this is what? 172.1.31. What? One less than 255, which is 254. Right? So when I ask you to find the last usable host address, the best way is you first find the broadcast address, right? And just do the minus 1. Subtract minus 1 from the broadcast address. Then you can get the last usable host IP address. Finally, let's just find out the number of usable host IP addresses. Okay, so the number of usable host IP address, right? So number of usable host, to find that number, you have to first what? You have to first count number of bits used in the host portion, right? So 4, right? And then what? This is 8. So the total of what? 4 plus 8 is 12. So total of 12 bits are used in the host portion. So answer is a number of possible usable host IP address is 2 to the power 12, right? 2 to the 12, and then minus 2. Why minus 2? Because you need to exclude the network address and then broadcast address. So that's why you need to subtract 2 from this number. So this is the answer. Number of so the number of usable host IP addresses. Number of host IP addresses, right? So that's the answer. So as you can see in the slide, 2 to the 12. You don't have to compute this number. So for the answer, this is good enough. Okay. Okay. I'm going to end my lecture here.